Hello everyone, we are from AQUAFIRE, here to present our hydrology group project BFC 32002. So without further ado, let's begin. So for the table of contents, we have 6 parts. Number 1, which is about our team. Number 2 is introduction of our project. Number 3 is methodology. Number 4, analysis. Number 5, discussion. And lastly, conclusion. Meet our team. So in alphabetical order, we have Afiq Aiman, Muhammad Zuhairi, Muhammad Akid Syamil, Muhammad Badrul Amin, and Muhammad Zuhizat. Introduction. So why do we choose Klang as our project location? So the most recent flood occurs on 16 December 2021 until 19 January 2022, which was the recent flood events in Kuala Lumpur. The worst affected area in Kuala Lumpur was Klang, where 3,086 residents were relocated to 30 temporary relief centres. So the information we collect originates from several stations in Kuala Lumpur. Analysis of rainfall data frequency, duration and intensity are used in the estimation.
Here is the methodology part. We collect the data from Department of Irrigation and Drainage website. Here we choose 3 stations for rainfall data and 1 station for water level data. Here is the station that we choose, which are we choose for rainfall, which are Sungai Taman Ehsan, Taman Desa Smart and Jambatan Petaling. Then station for water level is Sungai Klang at Jambatan Petaling. The information is gathered every day and is recorded for at least 4 weeks or 31 days. Next is analysis part. For arithmetic method, we choose rainfall data for 7 days as shown below, and then we get the value of P is equal to 18.67 mm.
The catchment are measured using Thyssen polygon method. The stations are Taman Ehsan, Taman Desa Smart and Jambatan Petaling. From the method, we will get the area and precipitation. The formula for the Thyssen polygon method is P equals to summation of AI times PI equal to summation of A, and we will get P equals to 15.67 mm. Isohydral method is a method to approach consider the orographic effect by calculating the area between the isohydrates after drawing estimated lines of equal rainfall to estimate the average precipitation in the watershed. For the isohydral method, we will get the isohydral interval, average precipitation, area, and area times average precipitation. For the calculation of average precipitation, the formula as follows, which is summation of area times average precipitation over summation of area, and the total of average precipitation is 28.18 mm.
So to find the hydrograph, we need first to calculate the discharge and the base flow. So in the base flow, we need to use 3 methods that will be suggested, and we are using straight line method. And this one is the sample calculation for cross section 1. Since we got a lot of information, but in order to find our discharge, there are several assumptions that we made. The first one is the shape of our river. For the shape of our river, we assume our river is on the trapezoidal shape, and then we can find the area, weighted parameter, hydraulic radius, and then the elevation and the distance to find the slope, which is S. And we use the coefficient, and coefficient for meaning is 0.06. It will refer to the table that we given on the report, and then we can find the V. Then we can find the discharge for every day from day 1 to under day 31. This is the sample calculation for discharge for cross section 1 in day 1. First of all, we used to use the R equal to A over P. R is hydraulic radius, like I shown earlier, area over by weighted parameter, and then we got the slope times by 100. We got this data. For roughness coefficient N 0.06, we assume the surface is regular cross section without boulder and bush. By using many equations, we can find the V. We substitute the number here, and then we got V 201.27 And then after that we can find the discharge for cross section 1 for day 1. We got the discharge on this value for day 1. So repeat this step for day 2 until day 31. So we continue our calculation. After we find the discharge, we need to find the base flow. So we are using a straight line method, which is from the first limb of the data, we obtain the straight line to the end, and then we interpolate the data between this and this to find the data for the base flow. And this is the data for base flow that we got after we interpolate the number from day 1 until day 31. And then we got the direct flow, which is discharge minus the base flow. And then we got all of this. We need to find the US ordinate to plot the graph. And this one is direct flow times with the equivalent surface runoff. And then we got the value here to plot the graph.
Calculation for direct runoff volume and equivalent runoff depths. Catchment area equals to 110.74 km squared. Total direct runoff volume total direct flow times 24 times 3600, and we will get negative 154.0661705. Equivalent runoff depths equals to total direct runoff catchment over catchment area times 1 over 1000 times 1 over 1000, and we will get the equivalent runoff depth is negative 1391.2 cm. The unit hydrograph as shows.
So to calculate the peak value using rational method, the first one we must refer to MASMA second edition, which is stated for peak value Q equal to CIA over 306. For ARA is 20 years, we need to find first the I, which is the intensity, and based on the MASMA given, we can find all the unknown here, and then substitute the value, and we got the intensity, which is 9.67 year per hour. So therefore our peak value, we just substitute the data, and then we got Q equal to 0.0026 meters.
So by using Q equals to AV, we can get the discharge for rational method. B, which is the width of the intervals, equals to 10. Depth is 14. After that, we just insert the values in the formula until we get the Q equals to AV. So for Q, we get 18536 meter cube per second. So the step is repeated and is used in cross section 2 and 3, which will be detailed in the report. Discussion.
There are three methods to calculate the mean area rainfall, which are arithmetic mean method, Hessian polygon method, and isohydral method. By using arithmetic mean rainfall, we got a total of P equals to 18.67 mm for 3 stations that we observed. Moreover, by using Hessian polygon method, the mean rainfall was P equals to 15.67 mm. Lastly, by using the isohydral method, P equals to 28.18 mm. This data indicated the number of mean rainfalls per area that being collected for the 3 rainfall stations at sample location.
For discussion for peak value and discharge of the river was the last part of data analysis. So we need to refer to the MASMA second edition, table 2B, to know the constant value and identify the based on the station that we have chosen. For TRI, we use 20 years, and our location is residential area. And storm duration we pick is 24 hours. So our intensity is 9.67 year per hour. And after that, by using the cross section, the same cross section for cross section 1, 2, and 3, we calculate the discharge for every river at the maximum water level. And for the result, we got 18,536 meter cube per second for cross section 1, and the data for cross section 2 in cross section 3 is similar, which is 12,008 meter cube per second.
Lastly, conclusion. As a conclusion, the discussion for the report addresses the whole study for this project. Furthermore, several issues that need to be considered, such as the accuracy of calculating the data, human errors, site that has been chosen, and several assumptions that have been made to complete this project. It is important to know that the study the stormwater and design of the drainage because it is an essential prerequisite for creating successful urban drainage and stormwater management projects. Lastly, additionally, to increase the accuracy of this project, several improvements have to be done, and it is crucial to decrease the errors and to make sure all procedure had been done efficiently. That's all from us. Thanks for watching.